So yeah, now we've discussed the big definitions and the big questions surrounding machine learning. I think it's important to then discuss some of the steps of machine learning, and this was discussed by Yufeng in 2017. So they described that there were 7 steps to machine learning. This involves collecting your data preparation, choosing a model, training, evaluation, parameter tuning, and then prediction. And in order to understand these steps, I've come up with a case study that allows us to create our own model. So I'm going to be talking through a case study and explaining how each steps apply to our case study. So let's just say that we have been asked to create a system that answers the question of whether a food item can be classed as an apple or as an orange. Now, this might be a really simple question, but this will help us to understand how we can go about choosing a model and how we can go about training our data set. So this question answering system that we build is called a model. And this model is created via a process called training. The goal of training is to create an accurate model that answers our questions correctly most of the time. But in order to train a model, we need to collect the data to train on, and this is where we begin. Step 1 is to gather the data. For the purpose of developing my machine learning model, our first step would be to gather relevant data that can be used to differentiate the 2 fruits. You can use different parameters to classify a fruit as either an orange or an apple, but for the sake of simplicity, I've taken 2 features, the first being the color and the second being the shape. So using these features, we would hope that our model can accurately differentiate between the 2 fruits. Now, typically you might have a model that includes way more features, but yeah, we'll be just using 2 features for today. So the data that we have collected here, the data that you see on the screen, would be your training data set. So we can then move on to step 2, which involves preparing your data. So once you have gathered the data, we then move on to the data pre-processing stage. And typically this does involve the biggest step. This can take up this is the most time-consuming step, depending on the complexity of your data set. A key focus of this stage is to recognize and minimize any potential biases in our data sets for the 2 features. So typically the first step you would want to do is randomize the order of your data for the 2 fruits. And this is because we do not want the order to have any bearings on the model's choices. Furthermore, we would examine our data sets for any skewness towards a particular fruit. This again would help in identifying any potential biases, as it would mean that the model would be adept at identifying one fruit correctly, but may struggle with the other fruit. Another major component of data preparation is breaking down the data sets into 2 parts. We have the larger part, which typically is around 80% roughly, and this would be used for training the model, while the smaller part, typically 20%, is used for evaluation process. Yeah, so this could be 80 to 20%, it could also be 70 to 30%, but this would always depend on your aims as a researcher. This is important because using the same data sets for training and evaluation would not give a fair assessment of the model's performance in real-world scenarios. Apart from the data split, there could be additional steps taken to refine the data sets. This would be dependent on what type of data you have, but this could include removing, for example, duplicate entries, or discarding for incorrect readings, or removing missing values. But luckily, we have a very simple data set, so there's not much that we need to do. Now, step 3 would involve choosing a model. Now, there are various existing models developed by data scientists which can be used for different purposes, but these models are designed with different goals in mind. For instance, some models are more suited to dealing with text, while other models may be better equipped to handle images. But with regards to our model, I think that a simple linear regression would be suitable in differentiating between our two fruits. So in our case, the type of fruit would be our dependent variable, while the color of the fruit and the shape of the fruit would be the two predictors or the independent variables. So this means that our features represent our independent variables. And just to recap, linear regression model, the linear regression model chosen here is an example of supervised learning. And this is because the outcome is known, so we can continuously refine the model itself until our output reaches the desired accuracy level. So now we can go on to step 4, which involves training. So here we use the part of the dataset allocated for training to teach our model to differentiate between the two fruits. If we view our model in mathematical terms, which you can see the equation on the top right of the screen, then the inputs, so our two features, would represent the coefficients, or would have coefficients, apologies, and then these coefficients are called the weights of features. However, it's not too important to discuss the mathematics behind a regression model. So once you have taught your model to differentiate between the two fruits, we would then have to take a step back and do some evaluation. And this is where we draw our attention back to the functions of an algorithm. And this looks at the decision process, the loss error, and the model optimization. This is where we would have to reevaluate our model and ensure that the decisions taken at the start, that the decisions taken at the start have the highest optimization. We then can move on to our step 5, which is the evaluation. And this is a very important step as well. So with the model trained, it needs to be tested to see if we can operate well in real-world situations. And that is why the part of this data set created for evaluation is used to check for the model's proficiency. So this puts the model in a scenario where it encounters situations that were not part of its training. So in our case, it could mean trying to identify a type of apple or orange that is completely new to the model. For example, we never identified green apples in our original data set, and this might need to be included in order to improve the model's efficiency. This also leads us on to our next step, which is the parameter tuning. So if the evaluation is successful, then we proceed to the step of hyperparameter tuning. So this step basically tries to improve upon the positive results achieved during the evaluation step. For our example, we would see if we can make a model even better at recognizing apples and oranges. And there are 2 ways we can go about improving the model. Firstly, you could revisit the training steps and use multiple sweeps of the training data set for training the model. This is because it could lead to greater accuracy, as the longer duration of training provides more exposure and can improve the quality of the model. Another way to go about this is to refine the initial values given to the models. Random initial values often produce poor results as they are gradually refined by trial and error. However, if we can go up with better initial values, or perhaps initiate the model using a distribution instead of a value, then our results could get better. I think it's also important to note that there is not a definitive approach for parameter tuning, as it would depend on the learning approach you choose, but also what type of variables you have present. And this leads us to our last step, which is prediction, which is what I've been honing in at for this whole talk. But yes, the final step of the machine learning process is prediction. This is the stage where we consider the model to be ready for practical applications. So our fruit model should now be able to answer the question whether the given fruit is an apple or an orange. It's kind of interesting to know that a model like this would gain independence from human inference and draws on its own conclusions on the basis of the datasets and the training. I guess one thing to think about, so the challenge for this model remains whether it could outperform or at least match human judgment in different relevant scenarios.